Hello everyone. So today I'll be going through practice exercise 10.1, chords of a circle. Okay, so we'll start off with question 7. So the chord AB is perpendicular to diameter CD. So AB over here, right? Perpendicular to diameter CD, right? And then center O, all right, at E. Okay, so AB equals to 70 cm. So this chord is 70 cm and CE over here is 25. So this is 25 cm and this is 70 cm lah. So part A, right, they want us to find the radius of the circle. Okay, so basically we are going to use this property, right? So because the question mentioned that CD is the diameter and it cuts AB, right? I mean, it meets AB at 90 degrees. So therefore, we can say that it's a perpendicular bisector of a chord. All right. So that means we can say that AE, right, is equals to DE, the length lah, right? So this is perpendicular bisect bisector of chord. So that means I can say that because AB is 70 cm, right? So AE is equals to 70 divided by 2, which is 35 cm. Okay, so AE here, this is 35 cm. Okay, and then they want us to find what? The radius of the circle, right? So if you see closely, right, OA is also the radius of a circle over here. All right, and then angle AEO over here is 90 degree. So let, okay, OA be R. Okay, so OA is RCM. And that means if you think about it, right, OE is actually equals to R minus 25, right? Yeah. So with this, right, we can actually form an equation using Pythagoras theorem. What is the equation? R square equals to 35 square plus R minus 25 square. Okay, so this is the equation that we will form. Okay, so let me just do some quick calculation. All right. So as you can see, right, so we have 50R equals to 1225 plus 625. So 1850. So R is equals to 1850 divided by 50, which is 37 cm. Okay. So this is my radius, 37 cm. So let's move on to part B on the left. So they want us to find the area of triangle A. Oh, so the entire triangle over here. This one. Okay, so basically very simple. Half times base times height lah, right? Okay, so we already know that the radius is 37, right? So we can find OE first. So OE is equals to 37 minus 25, right? Which is 12 cm. Okay, so we can use half times base times height lah, right? So area of triangle AOB, right, equals to half times the base, which is, okay, let me write out the formula. The base is AB, and then the height is OE lah. So half times AB, which is 70, times 12. Okay, so this will work out to be 420 cm square. All right, okay, so yes, this is it for question 7. Okay, guys, so let's take a look at question 8 together. So so there's a diagram over here, and it says that the cross section of a tunnel, right? So it takes the shape of the region bounded by the arc ATB. So this is ATB, all right, and the chord AB. So AB over here. So that means the tunnel is actually here. This is the cross section of a tunnel, all right, as I have shaded in black lah. Okay, so read on, right? And it has a circle with center O. All right, AB is 8 meters and the height of the tunnel is 8 meters. All right, so that means this part here is 8 meters. Okay, as shown by the diagram over there. All right, so find the radius of the cross section of the tunnel. So from a start, we can see that this is actually a straight line, right, that is passing through the center, right? And it will intersect the chord AB at 90 degrees and also cutting this AB into half. So let's label this part as C lah. So that means I can say that because AB is equals to 8 cm, right? AC will be equals to 8 divided by 2, which is 4 cm. Oh, meter, sorry, 4 meter. Okay, so this should be in meters lah, 8 meters. All right, because perpendicular, right, bisector of chord. All right. So after that, right, okay, because we want to find the radius, right? So this OA is the radius. Okay. And then OT is also the radius. So that means I can say that OC is what? So OC is also the is actually 8 minus radius lah. Right. So from here is actually quite similar to question 7. Right. We can form an equation using Pythagoras theorem. So, and this is OA is R. So R square, right, equals to 4 square plus 8 minus R square. So just manipulate this, right, and then simplify. Okay, so in this case, we have 16R equals to 80, right? R is equals to 5 meters. All right. And yeah, that's it. So this is it for question 8. Okay, let's take a look at question 9. So in this question, quite an interesting question. So the cross section of a piece of watermelon is in the shape of the part of a circle. So take note, PQ is not the diameter, as you can say, as you can see in the question. They say that part of a circle enclosed by the arc PWQ. So PWQ is actually the outside peel, right? The green color peel of the watermelon that you always see, right? And the chord PQ. So PQ is the chord. All right, it is not the diameter. So actually, if you think about it, right, it's actually a circle that is something like that. Okay, let me try and draw the circle using this. So probably something like that. Yeah. Okay, and then the center is somewhere probably around here. Okay, maybe not so far, maybe like here. Okay, so after that, they say the lowest point W is 7 cm from the chord. Okay, so that's 7 cm. And then find the radius of the arc TWQ. Yeah, so in short, just find radius lah. So if you think about it this way, it's actually something like that. They want the radius of this. So this is actually R, right? And then let me label this as center O, and this part here is A. Okay, so that means let OP equals to R, right, cm. That means PA, all right, PA is actually equals to 24 divided by 2 lah, 12 cm. Okay, so perpendicular bisector of chord. Okay, and then OA, right, is actually what? R, right? OA over here is actually R minus 7. Because OW is R, right? OW is R. And then AW is 7. Okay, so R minus 7 will be OA lah. Okay, so this part here, right, will be R minus 7. Okay, so same thing. Use Pythagoras theorem again for to form an equation. So R square equals to 12 square plus R minus 7 square. Okay, so R square equals to 144 plus R square minus 14R plus 49. So 14R equals to 144 plus 49. Give me a minute. So that will be 193. And R is equals to 193 divided by 14, right? Which is 13.78571. Round off 3SF, 13.8 cm. 3SF. All right, so this is it for question 9. Okay, let's take a look at question 10. This is the last question that I'm going to cover for exercise 10.1. All right, so quite an interesting question because there are two possible answers, right? So A, B, and C, D are two parallel chords of a circle of radius 15 cm. Okay, so there's no diagram given, so let's draw our own diagram lah. So let's draw a circle. Okay, and then let me try and duplicate this also. Okay, yeah. Okay, so center, right? Center, this, this. Okay, so they say that yeah, AB and CD are parallel chords lah. So AB is 24 cm and CD is 10 cm. So that means very clearly, right? CD is shorter. So shorter means it will be further away from the center. Likewise, if you are 24 cm, okay, because the radius is 15 cm, right? So that means the diameter will be 30. Yes. So that means AB, which is 24 cm, is closer to the diameter. Right. So there are two ways of drawing it. That's why they ask us to find two possible perpendicular distance from AB and CD. So it's like that. So it could be like that. This is CD, and then AB could be here. Okay. Maybe I should I should use the line something like that. Okay, like this, right? These two is like CD. And then one scenario is like this, AB is here, or it's closer, something like that. So there are two scenarios. So this is this is AB and then CD. Okay, so this is AB and then CD. So obviously the perpendicular distance for both scenario will be different, right? So this is the distance that I want to find out. This is the distance that I want to find out. Okay, I think it's quite clear, right? Yeah. So let's deal with the scenario on the left first lah. So because the radius is 15 cm, so that means I can say this. Uh, okay, let's take a look. So we definitely need to find. Okay, so I think I can draw these two lines lah. So this is 15 and this is 15. Okay, so like that, right? So let's label this as O. Okay, and then this part here is E, right? This is E, and this is F. Okay, so that means we know that OA is 15 and OC is also 15 because of the radius lah, right? So uh, we also know that AE, right? AE over here is going to be, okay, so scenario here, AE is equals to 24 divided by 2, which is 12 cm. Okay, so that means we can find what is OE lah, right? So OE is equals to square root. We're going to use Pythagoras theorem. Okay, maybe I write out lah. Write out in C. So we can say that OA square is equals to AE square plus OE square. Right, so I want to find OE lah. So OA square is 15 square equals to AE square, which is 12 square plus OE square. Right, so OE is equals to square root 15 square minus 12 square. Right, so let's do the calculation. So 9. Okay, so OE is 9. So I want to find out what is OF as well. Right, so okay, first thing first, we need to know what is CF lah. So CF is actually equals to 10 divided by 2 as well. So 5 cm. So CF here is 5. Right? So OF, we got to find out what is OF lah. So OF, right? Okay, same thing lah, Pythagoras theorem, right? So OC square is equals to CF square plus OF square. Okay, so OC square is 15 square equals to CF, which is 5 square, plus OF square. Take note, it's OF because it's the whole triangle, not EF. Okay, we got to find EF at the last step, right? So OF is equals to square root 15 square minus 5 square. So OF is 14, right? 14.14213. So lastly, I want to find EF, right? Which is the perpendicular distance between AB and CD lah. So EF is equals to 14.14213 minus 9. Okay, so that will give me 5.1421, round up 5.14 cm. Okay, so this is the scenario for the first scenario. All right. Okay, now for the second scenario. So second scenario, same idea. Let's draw lines again, right? Like that, like that. Okay, and then like that, and like that. So basically, we need to find what is the length here. Okay, so same thing. We are going to label this and as this is E and this is F. And then of course the center is O lah. Okay, so this is O. So same thing, AE over here is 12 as what we calculated just now, same, right? CF is also 5, we calculated just now, right? And CO and AO is both 15 because radius of the circle, right? So in this case, let's find out what is OE first lah. So OE square, should start with OA lah. So OA square equals to OE square plus AE square. So OA square is 15 square equals to OE square plus AE square, 12 square. So OE is actually equals to the working over here, if you realize it's the same thing, right? So this is 9 cm. All right, then the next part here, find OF lah. So same thing, OC square equals to CF square plus OF square. So same working, right? So OF is actually equals to 14.14213. So this part here is 14.14213. This part here is 9. So the perpendicular distance is EF, right? Still EF, but instead of minusing, we add. Yeah. So this is the difference between the two scenarios lah. So I'm just drawing it out so that it's easier for you to understand and to explain to you lah. So 14.14213 plus 9. So we have 23.14213 round off 23.1 cm. All right. So in both scenario, the first scenario, right? The both chords are together at the same side as each other lah. Means like okay, so you see O is here center, right? So these two chords are at the same side. Okay, but for the scenario on the right, right? The chord here is on opposite side of the center. So you see the center is here, AB and CD, they are on opposite sides. Okay, so that's why there's a difference between the perpendicular distance. All right. Okay, yes. So this is it for question 10.